everyone. Hope you enjoyed that reveal of key Zscaler, SD-WAN, and SASE innovations. Welcome to today's technical breakout session on designing a Zero Trust branch. My name is Amit Naik. I'm a director of product marketing here at Zscaler. I'm very excited to have joining me today Nuno Diogo, principal field product specialist at Zscaler. Some of you may know Nuno already. You may have spoken to him in the past, but he's been working with our customers on helping them deploy and implement Zero Trust SD-WAN. Nuno?
Thanks, Amit. And hey, everyone, my name is Nuno. And again, one of the field product managers focusing on Zero Trust SD-WAN here at Zscaler. I've been around, as Amit mentioned, for almost 5 years at Zscaler now, and excited to be with you guys, drilling in a little bit deeper into the topic.
So before we jump in, the question we want to ask is, why do we design a Zero Trust branch, right? So as you know, IT has been through tremendous changes in the last few years, especially with a few major shifts. So we've seen a shift away from everybody working in the office all the time to more hybrid workforce. We've seen the shift for applications moving to the cloud. Now we have another sort of a wave of shift with generative AI and applications, and we still don't know how that's going to impact us fully, right? And then the other big trend we see is a proliferation of IoT and OT in organizations. So Internet of Things, as one of my colleagues likes to call it, Internet of Threats, is a big problem for organizations as they don't have the visibility, they don't have full confidence on what the security posture is. And these are the key trends that are kind of forcing us to think about, how do I improve security in my branch? How do I bring Zero Trust into my branch environment? So having said that, Nuno, talk us through a little bit about what are the challenges with current architectures when you're trying to do Zero Trust, right? We know about Zero Trust ZTNA for remote users. We understand that. We've solved it. But what happens when you come into the branch environment?
Yeah, sure. And so, digging into all of those particular challenges, right, that you just talked about, IoT, hybrid workforce, users are in the office one day, working from home the other, applications are everywhere, right? So this all kind of goes back to that whole traditional perimeter continuing to be challenged, right? A perimeter these days, that traditional perimeter is fuzzy at best, non-existent at worst, right? Data is everywhere, users are everywhere, applications are everywhere. We understand that. And to your point, the Zscaler platform has allowed our customers to address user-based communications for these new challenging environments for quite a long time now, right? Our ZTNA fabric was in existence for over 7 years before ZTNA was even an acronym, right? Same thing for our SSE stack. Zscaler Internet Access has been around for 15 plus years now, well before SSE acronym became a thing. And so, as organizations try to make sense of all of these new architectures and trying to consolidate on, hey, I want to go to a place where it's simple and it's secure by design, right? So they start to gravitate towards this whole Starbucks model or iCafe model, right? A lot of common terms used by CIOs and CISOs these days to try to communicate the aspect of removing users from the network, from the traditional corporate network, from a risk mitigation perspective, right? Meaning that but when a laptop becomes compromised, that's another Zero Trust 101, right? One shouldn't assume a secure compute environment, which one should assume a compromised environment. So when that laptop becomes compromised, that malware has a much harder time propagating east, west, north, south within the environment because, again, that branch now is a Starbucks-like branch, meaning that it has no inherent connectivity to the rest of the corporate network, right? And that's great, and we've been doing that for quite a while now. But again, reality tends to set in and help us understand that branch offices where it's truly just users and their laptops are actually far and few in between, right? What about that printer that's sitting out there in the corner? What about that IP camera? What about that door badge reader? What about any number of things, including perhaps even server systems sitting in the back, comms closet providing local services? So how do we bring all of those things, those unmanaged devices where you cannot install an agent onto, how do you bring Zero Trust into the fold, right? And so if we look at how these infrastructures communicate today, how these things communicate, they are relying still on the traditional routed WAN that's been in existence for 20, 30 years now, right? And so that routed WAN, I'm talking about specifically that RFC 1918 based private WAN that we've been used to building, has some common challenges that are just pervasive. This is nothing new, by the way. This is just something that we as network professionals have grown to be accustomed to live with, right? That's a day in the life of. So when we talk about, hey, listen, if you have all of this interconnectivity, you have this complexity of maintaining route tables. Well, of course, right? You have to maintain BGP route tables. You have to redistribute it into EIGRP or OSPF, all the normal things, right? Now, let's say you have to do M&A. We'll get into that in just a second. Now you have to integrate new locations. Well, guess what? They use the same RFC 1918 address space that everybody else uses. So now you have overlapping IP address challenges, more complexity to have to resolve, right? But to me, really, the crux of it is the challenge is that when you establish a layer 3 connectivity, a link between two sites, regardless if it's via MPLS or IPsec tunnel, static or automated via SD-WAN orchestration, you're inherently creating an overly permissive path because that link, that VPN or MPLS, does what it's meant to do. It allows packets to go from one broadcast domain to another, right? So it allows for that communication. Reasons why, again, we as network professionals, we build these beautifully globally routed networks, and then the next thing we do immediately is what? We put firewalls everywhere because we believe in zero trust now as an industry. We believe in least privilege access. But we're still starting with a foundational architecture where everything knows and can connect to each other, and then we try to prevent them from doing it after the fact. Okay.
Yeah, and that's a very sort of network and location-centric view of
Exactly.
security, right? Which is what we've been living with so far, right? Where your access is determined by the network you've been allowed onto, right? And then we
Exactly.
had the suite of technologies like NAC, which to do admission control. But the problem right now is as users move around, that model no longer works.
That's exactly right, right? And I always go back to like, why are we still leaning on layer 3 criteria, IP addresses, as a designator of trust? Oh, you come from this IP, I trust you. Oh, you come from this VLAN, I trust you. Why? Right? But let's put that to the side for just a second. And to also highlight something that's specific to SD-WAN as a key challenge and a key expansion of the attack surface is this concept of SD-WAN gateways, and certainly not a poke at any of the SD-WAN vendors out there. I myself used to represent one of those back in the day. And so SD-WAN gateways generally are connected to DIA circuits, right? DIA1, DIA2, LTE backup, the normal constructs from an underlay perspective. And they can receive incoming IPsec tunnels from other locations, right? Either from the head-end unit at the data center, if it's a hub and spoke model, or peer devices, if it's a full mesh, right? And so inherently that means that you have an active IP listener on a public IP address that can be scanned and discovered by somebody on the internet to see if there's a zero-day or an unpatched vulnerability that can be exploited to gain a foothold into the environment and then go up stack and leverage these fully routable paths as a means to expand within the environment and look for those high-value targets to attach to and either exfiltrate or hold for ransom or whatever their intent is, right? And so what we're proposing instead is relatively simple. It is to expand the reach and the functionality of the Zero Trust Exchange, which again has been around for many, many years, to non-user workloads, right? Again, how do we grab that printer that's sitting at that logistics facility that needs to receive print jobs from the ERP system? How do we protect that in a zero trust perspective? How do we allow business to business communications take place again in a zero trust perspective? Or just how do we encompass all of these system to system communication? And so that's really just sending all of that traffic through the Zero Trust Exchange via a Z connector, and then allowing the Zero Trust Exchange to validate and broker those connections in real time, strictly based on policy, not because this VLAN is allowed to communicate with this other VLAN. Does that make sense?
Yeah. So it's a different model, and I think as we look through a few use cases coming up, it'll crystallize a little bit more for our viewers, right? As how this is helping them get away from routing overlays, right, and still achieve the objectives of at the end of the day, we're trying to allow users to connect to applications and resources, and trying to allow printers to fetch print jobs from print servers and IoT cameras to be able to connect to the cloud or to the DVR that's in the data center, right? And you can achieve these objectives using a slightly different approach. And let's take a look at how all of that works.
Yeah, so we do have a couple of deployment methods here. And so because we're talking about embedding or implementing this zero trust based overlay, right? So I'm using fairly technical terms, but this is for a technical audience that wants to learn a little bit more, right, and go a little bit deeper down the rabbit hole. So in traditional SD-WAN nomenclature, we have this concept of an overlay, right? The logical connection between things, and then the underlay, the actual the transport, where the packets, the zeros and ones, can actually put, right? And so on the left here, what we're depicting is where a lot of customers start, to be quite honest, right? Because this is a new approach. This is a different way of looking at the problem statement, right? I always go back to, instead of building the road and then worrying about how to protect the road, we're asking a different question. We're asking, should that road be built to begin with? Okay. And so we have the ability to do that as a zero trust overlay model with a one-armed or single-arm deployment, meaning that the Z connector is deployed within the branch or data center environment, and then traffic is redirected to those Z connectors, depending on the desired outcomes and criteria and what's in scope, right? So we can be very granular and very surgical here by leveraging your traditional policy-based routes and those types of mechanics to only send the traffic that we are interested in shifting over to the zero trust path or the brokered path versus the traditional routed path that is probably already in existence, right? That MPLS network or that SD-WAN overlay. So with this type of architecture, which is pretty common, customers are in full control of what goes via one path versus the other. The key here is that we are providing the zero trust overlay, but we are not touching the underlay at all. The underlay remains as current state, leveraging the existing capabilities of whatever happens to be in place. That could be a firewall, that could be an SD-WAN gateway with multiple DIA circuits, and those devices continue to be responsible to the underlay and decide what goes left, what goes right, and all of that normal structure. Okay. Now, the next evolution is for us to, for the Z connector to actually take responsibility of both establishing the zero trust overlay as well as handling the underlay, right? Because ultimately, if we think about branch architecture, less tends to be more, right? Especially thinking about our very large customers in retail that literally have thousands of stores, thousands of remote locations that they have to manage, right? Nobody wants to add more stuff to the branch. And neither does Zscaler, by the way, right? We are big believers in the thin branch, thick cloud type of architecture. And so with this design or with this architecture, the Z connectors actually goes inline as an inline gateway. So we become that edge device, and we give the customer the opportunity now to further simplify and consolidate their edge environment by leveraging the Z connector, not just again to provide that zero trust fabric access, but also to terminate ISP1, ISP2, do the typical load balancing or path-based selection and all of that normal stuff, including downstream VLANs, VLAN segmentation, etc. So another step towards unifying and simplifying and ultimately protecting the branch location.
Yeah, and then you want to move to sort of like this thin branch architecture and just really keep it really simple, right? Where you don't need to do a tech visit, right? It could be as simple for a non-technical person to unbox, plug in power, plug in an ISP connection, and you have a retail store up and running.
That's exactly right, and thanks for reminding me. Right, part of this construct again, taking a page out of SD-WAN, because SD-WAN did bring a lot of great ideas and great advancement. Again, 10 plus years ago, I'm dating myself. That's when I was representing such brands, right? So zero touch provisioning is what you touched on there, right? That process by which we don't have to go in there and manually configure anything. We configure everything in a cloud portal. We plug the device in. We drop ship it to the location. Somebody that doesn't have to be technical literally plugs cable into one port, plugs cable into another port, plugs it into power, and the device phones home automatically, registers serial number, authenticates with the certificate that's burned to the TPM chip, and attaches itself to the correct tenant, finishes provisioning itself, and you're off to the races. So that's absolutely all part of the solution here.
Yeah, and again, if you're interested in learning more, you feel free to reach out to us, and we're happy to talk to you one-on-one and walk through your particular use case. But let's take a look at some common use cases we see out there in the market, right? And one of the simplest ones, not simplest ones, but one of the most common ones we see out there is that most value is getting rid of site-to-site VPNs, right? VPNs are painful and clunky and hard to manage, and just sort of universally disliked at this point. Talk to us about how Zero Trust SD-WAN helps our customers eliminate VPNs.
Yeah, sure. And so on that topic, what's interesting to understand or to start with is like, why do I even have this VPN to begin with, right? It always starts like, why am I even doing this, right? And now that VPN it's a general term, and it could be used in many different constructs, right? It could be a VPN as part of that SD-WAN overlay fabric that we've been talking about, right? You look at on the wire, it's just another IPsec tunnel, okay? It could be a manually established IPsec tunnel between your data center and a business partner. Especially with large organizations, sometimes I have environments that literally have hundreds upon hundreds of these partner VPN tunnels. Okay, brings in a lot of complexity, going back to that overlapping IP address challenges, going back to overly permissive paths. But the reason why folks establish these IPsec tunnels is because they are bringing some sort of value, right? They allow this thing here, whatever this thing is, this device, this server, whatever that system is, to talk to some other system. So again, it could be a print server talking to a print device. It could be an IP camera sending video or clips to a centralized NVR. It could be a OT sensor sending telemetry to a data lake. It could be any number of things, but it basically boils down for system to system communication. That's what the focus here is. Okay. Again, remember users. We've solved that many years ago. We have an agent that is installed on the end compute devices. And even though I'm the quote unquote branch connector guy, I will tell anyone that will listen, if you can install an agent on it, please do that. Future you will thank current you, because that allows you to create the most contextual zero trust policy that you can possibly create, taking into account the device posture. Is it joined to domain? Does it have your EDR of choice up and running? All of those permutations. And so you can get very, very fine grained, or at least on our zero trust platform, on what that user in combination with that endpoint can access. Okay. For everything else that you literally cannot install an agent onto, that's what the Z connector is here for. And that includes on-prem workloads as well as cloud workloads. So lots of possibilities here as we continue to expand the reach of the platform. And so it boils down to system communication. Anything that needs to communicate to any other thing in a zero trust fashion without expanding the risk and the attack surface, this is a great architecture to consider.
Yeah, and one of the great examples of this that you and I have talked about before is remote printing, right? Mm-hmm. We have a lot of offices with printers. Often the print server needs to reach out to the printer and send a job to location. And often within the VPN world, what you have to enable is, again, unrestricted reachability between your branch network and your data center network, which has all kinds of security implications, right? So talk us through how we do it in the Zero Trust SD-WAN world.
Yeah, so I chuckle a little bit because I've been doing this for 20 years now. I date myself again, and I'm still surprised on how something as simple as printing can have such a severe business impact. So I'm thinking about all my logistics customers, right? And literally, if something doesn't print out from SAP, from their ERP of choice, whatever that happens to be, right? Those bills of lading, if that doesn't make its way down to the printer at that logistics facility, at that dusty warehouse, that bill of lading doesn't get printed. Folks don't know what to put on the truck. Product isn't shipped. Revenue isn't recognized, right? So just because that print shop didn't occur, or if that print process is compromised, God forbid, right? That can really hamper the business ability to actually recognize revenue. All right. So it becomes a pretty specific and a pretty critical aspect of it. And I have customers that literally deploy to these warehouses full stacks, firewall and switch and everything just to enable that print shop. All right. And so the way we do it is again, that simplistic approach, right? You deploy a Z connector at your data center or wherever you happen to have your ERP instance. You deploy a Z connector at your warehouse, your logistics facility. By the way, this could be a partner logistics facility. I have a lot of folks that rent warehouse space. It's not even their facility, right? They just have that little section of it, but they still deploy all this kit out there, this infrastructure in order to support this workflow. But by simplifying it, by simply deploying a Z connector on either end, now this print server will simply communicate that print job over the Zero Trust Exchange. Okay, so it goes from Z connector in the data center to the Zero Trust Exchange, the Z connector at the logistics facility outbound and outbound only into the Zero Trust Exchange. That's a key point because we do not expect or want our customers to open up any ports on their firewalls or to have any active IP listeners here on their public IPs, right? So everything is outbound based into the Zero Trust Exchange. And then the Zero Trust Exchange is responsible for validating policy. Yes, this thing can connect to that thing. And then stitching those connections or brokering those connections together, right? So now, quote unquote, magically, this print server now can send a print job to this print device without actually having to know what is the IP address of that print device, how do I route to it. All of that layer 3 stuff starts going away, and we're connecting at layer 7.
Yeah, again, once you get away from this mental model of having to connect two networks together, opens up a whole world of possibility, right?
That's right.
Whether it's third-party partners, you no longer have to connect the networks and or build VPN tunnels. Whether it's vendors, right? And you're going to talk about some of these use cases, but let's jump into sort of one sort of special case of this scenario, which is mergers and acquisitions. There's a lot of consolidation going on in the industry. A lot of our customers are acquiring regional companies or smaller partners, and they are now faced with the task of, okay, I've got two different sets of applications, two different networks, two different environments, two different identity stores. how do I bring this all together and realize the efficiencies to realize to the merger? Right?
Yeah, and we literally just heard Cornerstone share their experience and how much of an impact this has had in their time to value. So in M&A, again, one of my favorite use cases, because there's so much meat on that bone, right? It's board level directive, high visibility, high impact, right? And if we can shorten the time to value, the time by which those synergies start to pan out from months, most often years for large organizations, to a matter of weeks, as in the case of Cornerstone, there is tangible value to be extracted immediately. Okay, so now I'll use this type of example here, or this type of use case to go a little bit deeper on the mechanics of it. There's a bunch of numbers on here. I want to say 5 or 6 steps here, but I like to summarize them as 3 broad steps. Okay. And so the first step is, again, kind of logical, right? You deploy a Z connector. You deploy a Z connector within your organization, and you deploy a Z connector at the acquired organization's environment. All right. And I'll use a common use case here that's very repeatable. I've done quite a few M&A projects with my customers, and one that keeps coming up time and time again is Active Directory trusts. You know, allowing one domain controller in this organization to connect to another domain controller in the other organization in order to establish an AD trust, so that users don't have to manage multiple credentials and they can access resources on either end with a unified set of credentials, right? Which gives the IT organization and the M&A team plenty of time to then consolidate and sanitize everything and bring everything into one single AD structure. But right there out of the gate, week 1, you can actually establish an AD trust and allow users to access resources in a simplified way, in a secure way. So how do we do it? Again, step 1, deploy Z connector at each location. So you deploy Z connector in one data center, deploy Z connector at another data center where these domain controllers exist, for example, okay? And now we start going a little bit deeper down to the rabbit hole. And again, how do we decouple layer 7 from layer 3? Like, how do we access an application without having to worry to connect to the IP that actually hosts the application, right? The traditional model. And it starts with DNS. Okay, it starts with accessing things based on FQDNs, fully qualified domain names, all right, as opposed to going to an IP address. So that right then and there, you're elevating it, right? You're elevating the integration point. You're bypassing all of that jazz of overlapping IP address spaces and how do I route and all that stuff. How do I contain the risk? And so if step 1 is deploy a Z connector, step 2 is to have it have visibility into the DNS queries. Couple of different ways of going about it. In M&A environments, we typically do conditional forwarders. So we say, okay, if you just acquired Acme company and their internal domain space is acme.internal, we're going to redirect any DNS query for acme.internal towards the branch connector. Conditional DNS forwarder, pretty simple, all right? That allows the Z connector to recognize what is being requested. In this case, I want to connect to DC1. And when I say I mean the domain controller here on this side is trying to connect to dc1.acme.internal as an example. And so now the branch connector looks at that and is obviously always connected and tethered to our cloud and orchestrated by our cloud. And so it asks the cloud, hey, do I have something like something called the dc1.acme.internal in this environment? And the connector over here on this side said, yes, I actually do know what that is and I know how to connect to it. Use me to facilitate that communication. I'm kind of, skipping some key steps here. There's policy enforcement. There's all of this taking place, but nonetheless, say yes. I know what this application is. I can connect to it. Okay, there's a policy that allows you to connect to it. Go ahead. So the next step here is the branch connector, the Z connector at the site, returning what we call a synthetic IP. And a synthetic IP is a marketing term for a CGNAT range that's generated dynamically on the fly based on policy. So now the Z connector says, hey, you want to talk to the domain controller over at Acme? Talk to 100.65.10.5 or whatever IP address, whatever range we configure there. Okay, we tend to stick to CGNAT ranges so that there's no overlaps with RFC 1918, etc. So now it says, hey, go talk to 165.10.5. And now this domain controller will simply establish a communication for 100.65.10.5. And the Z connector at that location will grab it, encapsulate it, relay it over to the Zero Trust Exchange. The Z connector on the other end at Acme, let's say, will connect to the domain controller's real IP address on behalf of the requesting system on the left side, okay, and connect outbound to the Zero Trust Exchange. So it's these 2 outbound TLS connections that then meet in the middle in the Zscaler cloud and get brokered or stitched together. So now, without having to worry about any IPs or routing or establishing IPsec tunnels, extending SD-WAN or MPLS or any of that stuff that usually tends to take months, okay, you simply have this domain controller talking to this domain controller over the Zscaler cloud, and is being able to establish that overarching AD trust, allowing users to authenticate regardless of whatever domain they belong to. All right. So I don't know if I was successful in encapsulating this somewhat complex system into a short amount of time there. I mean,
I think you did a good job there, right? I mean, there's a lot of moving parts under the hood, but the big takeaway is like, so this is the magic that happens under the hood that enables customers like Cornerstone to take their integration time down from months to weeks, right? And start realizing value from their integrations much sooner. Really, really powerful capability. And, again, if you're the IT leader, if you can deliver this, the business is going to love you, right? And Zscaler helps you simplify this whole process. So jumping into, this is a great use case, of course, very powerful, very high value, but let's jump into a couple other use cases where the customers are getting value, right? So the next one is more around secure internet access or secure SaaS access, and whether this could be, a laptop trying to fetch software updates from the cloud, or a device trying to connect to its controller. How does Zero Trust SD-WAN secure that?
Yeah, so this is a pretty simple, especially in comparison to the previous example, right? Some moving parts there. This is relatively simple. It's really about grabbing that system generated traffic, that server operating system, that IoT, OT piece of kit that needs to connect out to the internet, right? Internet or a SaaS application. So what I normally see is, again, your typical server operating system needing to communicate to the internet for updates, download.windowsupdate.com and so on and so forth, other environments as such. And then as it pertains specifically to IoT and OT, a lot of these pieces of equipment, as I mentioned, are sensors. They collect telemetry, and then they have to relay that information to some sort of SaaS service that kind of actually allows their customers to make something, do something useful with that information, right? Make some intelligent decisions based on what that telemetry is representing. And so we have to ensure that they can communicate to the internet, because that's cloud connectivity today is basically a requirement for anything. Even my stove connects to the cloud these days, right? And so you have to allow them to connect, but you have to make sure they connect only to the things that, they need to connect to. Again, I always go back to, we live in a global supply chain these days, right? And these pieces of equipment get built from parts that come from everywhere in the world with the associated firmware. So it certainly wouldn't be the first time that I or my customers saw a piece of IoT kit come already compromised from factory with firmware that's phoning home and either exfiltrating data or doing something along those lines, or even providing a backdoor sometimes. So it's very important to ensure that yes, these things can communicate to the internet so they can fulfill their function, whatever that may be, but also that it's doing it in a way that is visualized, that we have control over, and that we know exactly what they're doing. Okay, so in this case, again, it's pretty simple. This traffic goes to the Z connector. Z connector encapsulates it and sends it to Zscaler Internet Access, another obviously a key component of our Zero Trust Exchange for SSL inspection, malware detection, sandboxing, the entire SSE stack that we have at our disposal before it goes out to the internet or their respective SaaS applications. So a pretty straightforward use case. You just need to send the traffic via the Z connector. That's all.
Yeah, and this is a great way to get slightly better security posture around IoT devices, right? Because with IoT, the challenge is dealing with so many different platforms and so many different operating systems, and many of these devices that can't do anything else with them. So one way you can get the security posture under control is by limiting what sites these devices are allowed to access to, right?
100%, right? Yeah. If you think about the attack chain, right, the process by which a threat actor kind of gets into an environment in a pervasive way, there's the breach, right? That's step one. But then there's reaching out to command and control, download second payloads, all that normal stuff, right? So if these devices cannot reach out and connect to command and control because they are limited in what they can connect out to the internet, then right then and there you're breaking that breach and the effectiveness of that malware to phone home and take subsequent actions.
Absolutely. The next use case I want to talk a little bit about is secure access to OT services, right? So this is an interesting one. We didn't think of this right off the bat when we sort of started developing Zero Trust SD-WAN, but this has been really popular with our customers. So we've had a solution in the market for secure privileged remote access into OT systems. But before we jump into that, tell us a little bit about the problem, right? Like, what are the challenges around remote
Sure.
access to OT?
It goes back to that whole, the world's a network, right? And so everything is solved at layer 3. And so when you have a vendor, a contractor that needs to connect into your OT environment in order for them to manage, update, or even operate those pieces of equipment that tend to be very specialized depending on what fields you are, the standard MO is to give them a VPN client and allow them connectivity into the environment, right? And then you look at Purdue models, you have jump host, you have all of that complexity, okay? And even with all those protections in place, time and again, how many times do we hear that a public breach, a very public breach, all started because a contractor's laptop was compromised and that contractor had VPN access into an environment, right? Time and time again, this happens, repeats itself. And so our approach, again, is very different because we elevate from layer 3. We say, why are we even allowing this contractor to establish a routable path from his or her laptop into an extremely sensitive area of our organization, into our OT environment, right? Regardless if it's jump host or not. And so with our architecture, as you can probably guess by now, the contractor does not connect to the customer's OT environment. The contractor connects to the Zscaler cloud. And oh, by the way, with a specific capability called privileged remote access, that contractor doesn't even need necessarily an agent installed on his or her laptop, which is actually a benefit to them, right? Because they have to manage umpteen clients, umpteen credentials, and jump from one to the other, etc. So this is all web browser delivered. They fire up a standards-based web browser. They connect to a portal provided by their customer. They authenticate via SAML. They have to provide MFA, and we give them a screen of only the things that have access to via RDP, SSH, VNC, Telnet, the usual protocols that are used in this context, okay? And so as the contractor connects to our cloud via a web browser, the Z connectors function within the environment is again to become that relayer of information or that broker of information, therefore connecting to the requested systems on behalf of the vendor, right, of that contractor, because that contractor, again, is not placed inside of that network from a logical, perspective, okay? And so now this piece of kit here will see the communication coming from the Z connector. The Z connector connects outbound to the Zero Trust Exchange, and that contractor, that vendor, is also connected to the Zero Trust Exchange. Inside of here, policy is analyzed. The connections that are allowed to go through are allowed to go through. The ones that are not allowed are not even established to begin with. There is no IPsec tunnel. There is no permanent connectivity amongst any of these things, right? And then PRA has some really neat features along the lines of credential mapping, session recording. The customer could even look over the virtual shoulder of the contractor while he's managing the equipment and all these things, right? So a lot of capabilities built into our PRA environment with more to come. Sandboxing of files, transfers, and so on and so forth. That's all already built in there. So pretty cool capabilities for this particular use case.
So again, if I were to sort of draw one thread through all of these use cases, right? I mean, I think the key takeaway is there's a lot of possibilities once you move away from the mental model of connecting two networks together to do anything, right? Mm-hmm. And this simplifies a lot of problems. This addresses a lot of security challenges, and it's a really, really powerful capability we're bringing to the market for our customers right now. So having said that, right? So as I think about our title slide and kind of the topic of this session around designing a zero trust branch, how do we summarize sort of everything we've learned here in this session, right? What are the 4 key takeaways we talk about while talking to that customers should take away from this session? And I think that the one theme that I tend to draw from this is around zero trust networking. Right. We've lived with a current stack of networking for almost the last 30 years. It's designed to solve different problems. Now in a world where we need to solve security problems, we need more flexible connectivity. We need to be more agile. And that's kind of bringing us into the zero trust networking world, right? And this is also forcing us to think about zero trust beyond users and devices as well.
That's exactly it.
What are your thoughts?
Yeah, I think that's the key, right? Embedding zero trust connectivity principles into the architecture of a network, not trying to overlay them after the fact, which is the status quo. The status quo is we build the roads, we pave them, everything can go super fast on them, and then we put gates and checkpoints everywhere to try and prevent stuff from working or from connecting. Because again, zero trust 101, we don't want everything to connect just because they can, right? And so it's a different perspective, a different mindset. what I would say I've seen with customers and how they're thinking, I think these two here are pretty well established at this point, right? Direct to cloud, direct internet breakout. That's been around for quite a bit, right? Not backhauling everything to the data center to go through the security stack. That's pretty much well understood and desired by and implemented by a lot of environments, and certainly the Zero Trust Exchange supports that and enables that. Okay, the cafe-like experience has also been a very prominent desire by my customers for the past year, going on 2 years now. Again, that Starbucks model. But here's the nuance. To your point, it's been very focused on users. So the user VLAN has no connection to everything else, and it's Starbucks for them. But what about everything else? Everything else still has that routed path, right? So it's kind of a split and a differentiation between, if you're a user, we treat you this way. If you're a printer, you have actual direct connectivity path, right? So there's some challenges there still. But these are pretty well understood. I think what's new and what really folks are starting to kind of gravitate towards is this whole concept of, let's embed these zero trust connectivity principles into the design of the network, making them available for not just users, but for everything within the environment. All right. And that, of course, includes IoT and OT. And IoT and OT, again, it's system-to-system communication, but because it's so critical, especially from an OT perspective, right, and stuff stops working, literally it stops the factory floor. There's different architectures. There's the Purdue model that tends to be the gold standard, but it's still all predicated on IP connectivity. So sometimes it takes time for an idea or a mindset to trickle from a user to a system to then OT until it becomes the standard, right? And that's kind of the path that we're heading down, and we're enabling our customers to go down this path of zero trust by default, period, end of story.
Yeah, and as IT has faced some very, very seismic shifts in the last few years, right? And as we sort of enter this new era, where there's more to come with generative AI. We don't even know. We haven't even begun to understand those, right? But as we're looking forward, I think we have a unique opportunity here to really rethink the way we architect branches and architect networks, and move away from the traditional WAN model, which is kind of fraught with security issues, and move towards a more secure zero trust future. So with that, thank you all for attending this technical breakout. I hope you found this very useful. And again, if you're interested in learning more or diving into any of these use cases, reach out to us to schedule a complimentary workshop and a demo. Happy to walk you through how we can Zscaler Zero Trust SD-WAN and SASE can solve your unique challenges and get you simplify, secure, and transform your network.
Awesome.
Thank you, Nuno.
Thank you, Amit.
Thank you to
It was
our
a
viewers.
pleasure. Thanks all.